Okay, today I'm going to teach you about horizontal asymptotes, which is this part. But you already know this part, and this part. So let's start by finding this problem right here in the notes that are posted. It'll be probably the second page, I think. Then factor the top and factor the bottom. Then we'll be ready to begin. I will pause while you do that. All right, so we need to get to this one. Hopefully you have factored it and you have said that it's x and x. Okay, I want you to get that onto the right place now. X and this is plus 4 and minus 1. And this one is x. I'm going to guess it's minus 1. Do you know why I think it's x minus 1? Because that can't be a 4, because it has to multiply to be 3. And one of these two is probably going to cancel with it, right? So I'm going to guess pretty high probability that's an x minus 1 there. And then I'm going to figure out what would the rest be, x plus 2, and let's see if that actually works. Outside, inside. No, 3. Sorry. Outside, inside. And that works, yes. Okay, then I would do these from the bottom up. Start with the whole. And what is the whole on this one? That and that cancel. And the whole would be at 1. Do you get, though, that I cannot just leave it at 1? I was telling you yesterday that this is a big deal. You have to have the other part of the whole. How do you get the other part of the whole? You just take the 1, you plug it back in. So I say y equals whatever's left after this stuff cancels. X plus 4 is left on top, x plus 3 is left on the bottom, and then I put the 1 in for x. See, that's what it is. It's an x, so I put it there and there. And that would make 5 over 4, so 5/4. Do you get how I find that whole? That's really important. Okay, next thing is the verticals. The vertical asymptotes, those are the x things. Try to picture this V making kind of like an x. Those are x equals things. And they are the x equals things that also crash the function that are not wholes. Now, of these two, the 4 and the 3, which one actually makes the asymptote? The -3 or the -4? -3. Because that being 0 wouldn't be a problem. It's okay to be 0 on top. Some of you are not looking up here. It makes me wonder what you're looking at on your iPad. Please stay with me. So I just found the other thing that makes this equal 0. Not the whole. We already did that. It's the other thing that makes it 0. Next thing is the domain. And you say all reals, except x cannot be these things. That or that. So you say x cannot be 1, because that's where the x is. And x cannot be -3. There's my domain. Now the horizontals is the new thing for today. How do you decide what the horizontal asymptotes are? If I just gave you this, it's actually very easy to say what the horizontal asymptotes are, but you don't know the little rules yet. So I'm about to teach you those. All right, take a look at this. You'll need to take some notes on this. I wouldn't write down all of this, but I would write down Bob, bigger on the bottom, and y equals outside. And all it looks like y equals 0. And a lot of times the answer is y equals 0. But it's not always. And I want you to be smarter than just saying y equals 0. Some kids are going to be taught that way. I taught it that way before. But now I'm teaching it as y is whatever's on the outside of the fraction. Do you get that there is nothing on the outside of this fraction? And therefore the answer is y equals 0 for that one. But as soon as I change this by like putting plus 5 and the whole function moves up 5, you've seen that before, right? As soon as I do that, then this way doesn't work anymore. It's not y equals 0. It's y equals whatever's on the outside. So if I put a plus 5 out there, it can be y equals 5. Nope, there's nothing on the outside of this like being added. Being added, not multiplied. Because you're right, you could say multiply by 1. I'm talking about whatever's added out there. Again, I'm going to go to another situation. Let's say you had this 1 over x. Do you get that that graph kind of looks like that? That one? And what if I asked you what is the asymptote running this way? Do you see it's at 0? Okay. But what if I took this whole thing and I went like this? Plus 3. Do you get how the whole function would have to move up 3? And so the asymptote line would have to move up to here. And so now it can't be y equals 0 anymore. It's whatever's on the outside. The asymptote is going to be whatever's on the outside of the fraction. All right, back to the next kind. This is, again, something I would want to take notes on. Bigger on the top, there is no asymptotes. Now, this one's bigger on the top. How do I decide what are we judging by? It tells me it's bigger on the top versus bigger on the bottom. It's the degree of it. Now, I'll talk through that in just a second, but let's get through this last one. Same on both. Of course, they could be the same on the top and the bottom. You're either bigger on the top or it's bigger on the bottom, or they're both the same. If it's the same on both, those will make you sob because they're so much harder. That kind of a problem is where you take the lead coefficients and you divide them. It's called a ratio of the lead coefficients. And so a typical answer would be like this. What's the lead number on the top? 1. What's the lead number on the bottom? 1. So I'd say it's y equals 1 over 1 equals 1. All right, I'm going to give you a few, and I want you to tell me. What do you think? Is it bigger on the top or bigger on the bottom? Bigger on the top because it's about the degree. All right. Is it bigger on the bottom now? Nope, it's not. It's the same on both now. Do you get why it's the same? Because x means x squared. And it's about the degree of it. All right, so let's look at this one. X plus 3 times x plus 2 all over x cubed. Is it bigger on top or bigger on the bottom? Bigger on the bottom. Good. By the way, what was the degree on the top? 2. Because when I multiplied this puppy out, I'd have an x times an x. That would make an x squared, wouldn't it? That's why it's degree 2 on top. All right. So now, let's go to the asymptote part. Let's say I got it figured out that it is bigger on the bottom, which it is. Then what's the asymptote for it? Y equals, these are always y equals things. Y equals what? Bigger on the bottom. It's an outsider, so what's on the outside? So it's y equals 0. All right, we're talking about horizontal asymptotes right now. So the question will look like this, and it'll be asking for horizontal asymptotes. Let's look at this one. Bigger on the top, bigger on the bottom, or same on both? Same on both. So it's a ratio of the lead coefficients. The lead coefficients are 1 and 1, so it's y equals 1. There's my horizontal asymptote. Let's look at another one. It's asking me the horizontal asymptote again. Let's just do that part first. Is this bigger on top, bigger on bottom, same on both? Bigger on top, what's the rule for bots? There's none. I like to see it like robot. There's no bots. Get it? All right. So it's a bot bigger on top, and there's none for that situation. Anytime the fraction is bigger degree on the top, there are no asymptotes. All right. How about this? What's the whole? Well, I need to factor this. X plus 4, x minus 4. On the top, would you assume one of these would be x plus 4 or x minus 4? Yeah, I would. And do you get that this thing divides into 2 parts? And we can do one of those kind. X squared, and then guess what I have? X minus 4. And then I take out a 2 out of these 2, here and here, and I have plus 2, and then what's left? X minus 4. And now, see if you can hang with this. You can cancel one here and here and here. Why? Because that top one there's 1 in each of them. Another way to say that is, I could just take the top and factor it like this. Put the x minus 4 in front, and then put the x squared plus 2 last, and then don't even need this anymore. And now can you see that the x minus 4s will cancel? Cancel, cancel. All right, and so what does that make? That makes the whole at x equals 4. But I really want the whole point, 4 comma what? And I put the 4 back in to figure out what I'd have left. 4 squared is 16 plus 2 is 18 over 4 plus 4 is 8, 18 eighths. What's that reduced to? 9 fourths. Right. The vertical asymptotes, that's whatever also crashes it, but it's not a whole. That also crashes my function. So x equals negative 4. The domain is all real numbers except the things that would have crashed it. All real numbers except x cannot be negative 4. See, that would crash it. Wouldn't this also crash the function? Yep. X cannot be 4. There's my domain. Any questions about how to do that kind? Yes. Big R stands for all real numbers. If you want to write out the words all real numbers, go ahead. But if you'd rather just write the big R, it's got 2 straight lines for it. I'll make one. That stands for all real numbers. It's just one of those little symbols you can write instead of writing out all real numbers. And then you say all real numbers except the numbers cannot be this, this, and this. You make a list basically because everything works except 2 things. What the ones that don't work? They're the things that crash the bottom of your fraction. So this got factored into this and this. These would both be asymptotes except this one isn't an asymptote because it's a whole. The thing where it cancels the top and the bottom. So let's just do one more like that. Right there. Would you factor the top, please? And then factor the bottom. And see if anything cancels. If nothing cancels, then there's just no holes. The vertical asymptotes are the other things that crash your function. So I would start bottom up. And it's tempting to put an x plus 3 down in the bottom, but if you actually try it, x plus 3 and x minus 5, it doesn't work. So don't get sucked into that. It's x minus 3 and x plus 5. Now the outside, 5. The outside and the inside will make my positive 2x like it's supposed to, and nothing cancels. So there's no holes. Verticals, whatever makes this thing crash. So verticals, you're looking at the denominator. X equals 3, x equals negative 5. Raise your hand if you knew that. Okay, good. Next part, horizontals, is this. Bigger on top, bigger on bottom, same on both. Bigger on the bottom, what's the rule on Bob's? It's not always y equals 0. It's whatever's on the outside. And since there is nothing being added, see, all I'd have to do to change that is if I put like a plus 5 on the outside, then the answer would be y equals 5. You get that? All right, so it's y equals whatever's on the outside. In this case, it's 0. There is nothing on the outside. Okay, the domain. The domain is everything works except, so I start with all reals, except x cannot be what? All of these things. So x cannot be 3, and x cannot be negative 5. Can it be 0? If I put a 0 in here, I'll end up with an answer of 9 over negative 15. That's not a problem. 0's okay. And again, this is a y thing. That's why we don't include it in the domain. All right. Only other thing is you got to know how to write these. There's a little section on your quiz on Thursday on writing these equations. I want to do a couple of these with you. If we do a couple every day, you'll be good at them by the time they happen. Ignore the hole. It's like it's not even there. Then what would the equation for this line be? Y equals 1. So put that. Then make it a fraction. And then, if it really does have a hole right there, you have to add in something. Like that. Something that would cancel. What would cancel? I want an x minus 3. That way there'll be a hole at 3. You get that? So my equation's right here. That's my equation for that line. It's got the hole in it. All right, here's another one. See if you can do this one without my help. Don't forget the y equals, because these are equations. If you don't have the y equals, I can't give you the credit. Give it a shot. I believe you can. Now, for some of you that are struggling with this, ignore the hole for a minute. Just act like it's not there. What's the equation for the line? Well, it's a straight line that's going through the point 4. I mean, that's touching at 4. Does that seem important to you? So you should say, and what's the slope of it, by the way? It may be hard to tell because this line's a little tilted, I think. That's better. You see that that is a straight line that's got a slope of 1. So it should be y equals x plus 4. That's without the hole. Then you have to add in the hole, which would be like one of these. And you better put parentheses around this too to make it work right. And then it has a hole at x is 1, x minus 1, x minus 1. There's your equation. Act like the hole doesn't exist to figure out your answer. Then go back and put the hole in as just a little factor over another factor at the same side. Alright, that's how you do that stuff. Your homework is the one for today under today's date of 12/17. There'll be problems just like we just did on the board there. The horizontal asymptotes is the only new thing. Bob, bigger on bottom. Y is an outsider. Bot, bigger on top. Y equals, there is none. And the last one was SOBs. And they're the ones that are the same on the both, same degree on top and bottom. And those are a ratio. Y equals a ratio. Yes.